Students, so let us start 13.3 also. 13.3. So metallic sphere of radius 4.2 cm is melted and recast into the shape of a cylinder of radius 6 cm. Find the height of the cylinder. Okay. So radius of the metallic sphere is equal to 4.2 cm. Okay, radius of the metallic sphere is 4.2 cm and radius of the cylinder is equal to 6 cm. Okay, so you have to find the height of the cylinder. Okay, so now students, a metallic sphere of radius 4.2 cm is melted and recast into the shape of a cylinder. So sphere is melted to form the cylinder. So therefore volume of the cylinder is equal to volume of the sphere. So volume of the cylinder, students, pi, radius of the metallic sphere is considered to be small r and radius of the cylinder is considered to be capital R. Volume of the cylinder is going to be pi, capital R square capital H, and volume of the sphere 4/3 pi small r cube. So what I will do is, here you see pi and pi will be cancelling on both sides. So capital R is 6 into 6 into H, and 4/3 into small r is 4.2, so 42/10 into 42/10 into 42/10. So this 3 I can cancel. 3 1 3, 3 1 3, 3 4 12. Next, what I will do is, students, just see H is equal to, I will not multiply this all. 4 into 3 is cancelled. So 4 into 40, 4 into 40 into 42 into 42, and below I will take this to 6 into 6, 10 into 10 into 10. So what I will do is I will just cancel 7 times, 7 times. So here X is equal to, I will get 1000. So 4 into 40 is 56. 56, so it's going to be 49. So 9 6 are 54. 9 6 are 54. 4 5 9 9 into 54. 4 9 into 45. 50. 4 4 20. 22. 4 4. 2744. So that is F is equal to 2.744. So therefore number 1, therefore height of the cylinder is equal to 2.744. Okay, so we'll just see the sum, students. So see here, the sum is like this. So the sum is short. One metallic sphere is there. Consider this to be a metallic sphere. Okay, consider this to be a metallic sphere. So in the question they said that a metallic sphere of radius 4.2 cm, a metallic sphere of radius 4.2 cm is melted and recast into the shape of a cylinder of radius 6 cm. Okay, find the height of the cylinder. Here you see this is a metallic sphere. This is a metallic sphere. This metallic sphere is melted. Okay, this metallic sphere is melted, and whatever we get after melting this metallic sphere, we will form this cylinder. Understood? So this metallic sphere is melted to make this cylinder. Okay, so therefore radius of the metallic sphere I got small r, and radius of the cylinder is capital R, 6 cm. And now then I have volume of the cylinder is equal to volume of the sphere. Can I write this? You see, because from the sphere only the cylinder is made. After melting this sphere only the cylinder is made. Therefore the volume of the sphere will be equal to the volume of the cylinder. Understood? So that is what we did here. Volume of the cylinder is equal to volume of the sphere. Volume of the cylinder, just write the formula pi r square h. Okay, pi r square h. And volume of the sphere will be 4 by 3 pi r cube. Pi and pi is cancelled. So capital R, what is the value of capital R? 6. So write 6 into 6 and into capital H. 4 by 3 into radius, small r is how much? 4.2. So write 42 by 10. 42 by 10 into 42 by 10 into 42 by 10. So with this 3 you cancel 42 14 times. So just now you multiply 4 into 14 into 42 into 42. 4 into 14 into 42 into 42. I will multiply. Okay, if I multiply I will get a bigger number. That is even harder to cancel. So I will multiply. I will just keep the numbers as it is. Here I wrote. And this 6 into 6 I am cross multiplying on the other side. Now with this 6 I can easily cancel 42. With this 6 I can also cancel 42. So 4 into 14 into 7 into 7 will become 2744, and below I will get 1000. So if I remove this, if I divide 2744 with 1000, I will get 2.744 centimeter. Therefore, height of the cylinder is equal to 2.744 centimeter. Okay. So, students, let us see number 5. A container shaped like a right circular cylinder having diameter 12 cm and height 15 cm is full of ice cream. The ice cream is to be filled into cones of height 12 cm and diameter 6 cm having hemispherical shape on the top. Find the number of such cones which can be filled with the ice cream. So, right circular cylinder, diameter 12 cm, this is 12 cm, and the height is 15 cm. 15 cm. And the ice cream is to fill into cones of height 12 cm. Cones of height 12 cm and diameter 6 cm. Cones of height 12 cm and diameter 6 cm. So for the cylinder, height h is equal to 15 cm, diameter having diameter 12 cm, and height 15 cm. Okay. Radius is 6 cm for number of cones that can be filled is equal to volume of cylinder divided by volume of hemisphere plus volume of cone. Cylinder by r square. Volume of hemisphere will be 2.35 small r cube. Volume of cone will be 1/3 pi r square h. So students, what we will do is we will take here pi r square h is value. I will take common here. I will take 1/3 pi r square common. 1/3 pi r square. What is going? 2 will stay here. I will stay here. 1/3 pi. Pi and pi is cancelled. And put the values down. The value of capital R now is 6. So 6 into 6. And h is 115. So that's 15. 1/3 into small r. Small r is how much? Small r is 3. And 2 into 3. And 2r. 2r. So 2 into small r is what? 3. Small r is 3. And h. So this 3 is cancelled. With this 3 you cancel 6 2 times. So 2 into 6 into 2 into 6 into 15. This is 6. This is a 6 plus 12. So 2 into 6 15. And below how much? 15 into 6 and 3 times 12. So here students, number 5. A container shaped like a right circular cylinder having diameter 12 cm. This is a container. This is a container that is full of ice cream. Okay. This is a container that is full of ice cream. So the diameter of the container is from here to here is 12 cm. And what is the height of the container? Height of the container is 15 cm. Okay. Now what is happening is that from here the person who is giving you ice cream, he is taking the ice cream from here and he is filling this up like this. This cone is filling this up. Okay. Fully he will fill and above he will create a hemisphere. Understood? This conical part will fill fully and above we will create a hemisphere. Okay. So now such type of cones, how many such cones can you fill from this by taking ice cream from this cylinder? Okay. How many such cones? So the basic idea is there, students. The basic idea is there. What we will do is that volume of the cylinder divided by volume of the hemisphere, because above one hemisphere is there, no? Above one hemisphere is there, isn't it? So volume of the cylinder divided by how did I find out this? Number of cones that can be filled is equal to volume of the cylinder. Above I put volume of the cylinder and below I will put volume of the hemisphere plus volume of the cone. Okay? Volume of the hemisphere plus volume of the cone. So what is the volume of the cylinder? Volume of the cylinder, what will you write? Volume of the cylinder formula is pi capital R square H. Capital R is the radius of the cylinder and capital H is the height of the cylinder. Okay. And volume of hemisphere, how will you find out? If the full sphere's volume is 4 by 3 pi r cube, then hemisphere will be 2 by 3 pi r cube, and volume of the cone will be, students, 1 by 3 pi r square h. So what we will do is, from here and from here I will take 1 by 3 pi r square common. From here if I take 1 by 3 pi r square common, see 1 by 3 I will take, from here I will take 1 by 3 pi and r square. 1 by 3 if I take, then 2 will stay, pi I will take, and r square I have taken. 3r is there, no? 2 I have taken, so r will stay. Again, from here also I will take 1 by 3 pi r square common. From here also I will take 1 by 3 pi r square common. So what will stay? H will stay. Now see here, this pi and pi is cancelled. So capital R, what is the value of R? 6. So write 6 into 6, isn't it? The radius of this container is 6. This is the container where ice cream is kept, isn't it? So if the diameter is 12, what will be the radius? From here to here will be 6. So write 6 into 6, and capital H is what? 15. So 1 by 3 into small r square is 3 into 3, and 2 into small r is 3, and small h is 12. So this, with this 3 you cancel this 3. With this 3 also you cancel this 6 2 times. So 2 into 6 into 15 you will get, and below you see 2 into 3 is how much? 6 plus 12. Very easy calculation. Okay. So 2 into 6 into 15 will keep it as it is. 6 plus 12 will be how much? 18. So with this 6 you cancel 18 how many times? 3 times. With this 3 you cancel 15 5 times. So 2 into 5 10 joules. Okay. Students, let us see one more sum. Number 8. Okay. So water in a canal 6 meter wide and 1.5 meter deep is flowing with a speed of 10 km per hour. How much area will it irrigate in 30 minutes if 8 centimeter of standing water is needed? Okay. So for the canal with D is equal to 6 meter, depth H is equal to 1.5 meter, and the water is flowing at the speed of 10 km per hour. Okay, so that means length covered by the water in 60 minutes is equal to 10 km, that is 10,000 meters. Okay, so length covered by the water in 1 minute equal to 10,000 by 60 meters. In 30 minutes is equal to 5,000 meters. Okay, so therefore length m is equal to 5,000 meters. So then for the feet, height into 8 centimeter, convert to meter, 0.08 meter. Okay. So now students, so area, volume of water that flows through the canal is equal to volume of water in the field. Okay, so this side it will be L into B into H, and this side it will be L into B into H. So length is 5000, breadth is 6, and the height is 1.5. So L into B into H, H is how much? 0.08. So 5000 into 6 into 1.5 divided by 0.08 into B. So 5000 into 6 into 15 into 100 by 8 into 10 and into B. We will do this also. With this 8, this 8 cancel 5000. 5000 divided by 8, 8 6 are 48, 20, 8 2 are 16, 40, 625. 625. So L into B is equal to, so 625. 625 into 625 into 6. 625. 6 into 15. 6 into 15 is how much? 90, isn't it? 945. 9 and 45, 4, 18, 22, 24, 56, 0, 5, 2, 6, 5. 5, 6, 2, 5, 0, 0, which is therefore area irrigated is equal to 5625 0 meter square. So students, so you see here, water in a canal 6 meter wide and 1.5 meter deep is flowing with a speed of 10 km per hour. How much area will it irrigate in 30 minutes if 8 centimeter of standing water is required? Okay, so that means canal you have seen, all of you. I hope all of you have seen canals. Water canals like this, isn't it? It is in the shape of a cuboid. So water flows through this, isn't it? Water will flow through this canal, isn't it? Through this canal the water will flow. Okay, so canal is a cuboid. The shape of the canal is just like a cuboid, this shape. The shape of the canal is just like a cuboid. You see here what is given. What is given is there The water in a canal is 6 meter wide. Okay, this canal is 6 meter wide. See here, the width of the canal is 6 meter. The width of the canal is 6 meter. And what is the depth of the canal? The depth of the canal is 1.5 meter. And the water is flowing at the speed of 10 km per hour. So how much area will it irrigate in 30 minutes? Okay. So if how much area will it irrigate in 30 minutes if 8 cm of standing water is required? That means in the field, have you seen rice fields? In the rice field, water is standing water is required, isn't it? So here also standing water is required. Okay. So let us see. For the canal, width of the canal is how much? Width of the canal is 6 meter. Okay, this width of the canal is 6 meter. And what is the depth of the canal? Depth of the canal is 1.5 meter. So length covered by the water. What is the speed of the water? Speed of the water is 10 km per hour, isn't it? That means 10 km if you convert to meter, 1 km is 1000 meters. 10 km will be 10,000 meters. So length covered by the water is 60 minutes. Length covered by the water is 60 minutes is how much? 10,000 meters. So length covered by the water is 1 minute is 10,000 by 60. So length covered by the water in 30 minutes will be 500 by 3 into 30. So it will be 5,000 meters. Isn't it? So total water will cover how much land? 5,000 meters. So what will be the length then? The length covered, the length, that means water is flowing through the canal. Now you have to consider that this canal is this much. The length of the canal is 5,000. Not the actual length. Okay, the canal may be long, the canal may be small, but you have to consider that a cubert whose length is 5,000 meter, and width is 6 meter and height is 1.5 meter. How much water in that canal will be there? That much water will only flow in the agricultural field. Understood? Because what is the speed of the water? Speed of the water is 10 km per hour. From there we found out that in 30 minutes, how much water will, what length of water will flow? 5,000 meters. So for the field you see, what is the height of the standing water required in the field? 8 cm. 8 cm is converted into meter, divided by 100, so it will become 0.08 meters. Now volume of water that flows through the canal is equal to volume of water in the field. Volume of water that flows through the canal, how much water is flowing through this canal, that much water will only flow in the field, isn't it? So volume of water that flows through the canal is equal to volume of water in the field. So volume of water that flows through the canal. So canal, what is the length? Length is 5,000, breadth is 6, and the height is 1.5. So L into B into H, because the canal is a cuboid. And volume of water in the field, students, field also you consider to be a cuboid. L into B, length, breadth, and what is the height? Height is 0.08. So in case of height you put 0.08, length you put 5,000, breadth you put 6, and height you put 1.5. So 0.08 you just bring it down. Now after calculation you see how many places before decimal is there? 2 places before. Just remove the decimal, above you multiply by 100. Above 1 place before decimal is there, remove the decimal, below you multiply by 10. Then with 8 I cancel 5,625 times, and 0 and 0 I cancel. So all these terms I multiplied, I got 562,500 meter square. So therefore area is how much? 562,500 meter square. Okay. So just imagine, just think about this thing. Width of the canal is 6 meter. So this width is 6 meter. Length is not given. Okay. Height is given. This height is 1.5 meter. So length we will find out from the data given. From the speed. What is the speed of water? 10 km per hour. So if the water flows for 30 minutes, how much length will flow? 5,000 meters. So this we will consider as the length of the cuboid. Okay. Understood? So in this canal, how much water? If a canal is considered that is 5,000 meter long and whose breadth is 6 meter and the height is 1.5 meter, how much water is present in that canal? That much water will only flow in the agricultural field, isn't it? So in that way we will find the area of the irrigated. Area irrigated is how much? 562,500 meters square. Okay. So thank you students. This was only for today. We will continue with our regular online classes. Thank you. Have a nice day.